The formulation of the modern periodic table made life simpler for scientists working in the field of chemistry. It was a boon for people working with elements. Now, let us also understand the modern periodic table in order to form a strong base for learning chemistry. Well, we need to first understand how these elements are clubbed together. That is the pattern of columns and rows. If we take a look at the table, we find that the elements are arranged in around 18 columns, whereas the number of rows is 7. The 18 vertical columns are referred to as the groups. Each group is a family of elements with similar properties. So let's talk about these groups first. In any of the groups that you select to study, you will notice a common trend. Let's take the example of the 17th group to study it. We find elements like fluorine, chlorine, bromine, iodine, and so on. What do you think is similar in all these? Let me give you a hint. Just have a look at their atomic structure. Yes, they all have the same number of valence electrons, which is 7, right? Thus we can say that the elements belonging to a particular group have same number of outer electrons. So can we even say all the elements in one group have the same valency? Yes, absolutely. What is valency? Valency of any atom is defined as the capacity of that atom to give or take the electrons during bond formation. But if you notice, the number of shells increases as we go down in the group. So how is the same valency possible? It's easy to understand. The valency depends only on the number of valence electrons and not the number of shells. As we go down in the group, only the number of shells increases. However, the number of valence electrons still remains the same. All the elements have 7 electrons in the outermost orbital despite the different shell numbers. This is why the chemical properties of elements in a group remain the same. So now you know how elements form a particular group. Now let's talk about the horizontal rows. These rows are called as periods. Here, we do not find similar properties of elements. However, the typical characters of elements are seen increasing or decreasing as we move from left to right in a period. What exactly are these typical characters? The typical characters refer to the metallic properties, non-metallic properties, and so on. Do we mean that these typical characters change across the period? Yes, they do. That is because elements belonging to a period have identical number of shells in their atoms. But these do not have identical number of valence electrons. That means the chemical properties would change as we go from left to right in a period. Let's consider an example to understand this. Let us focus on the third row. In this period, we find elements from sodium to argon. Now keeping argon aside, since it's an inert gas, we consider the list till chlorine. Let us have a look at the structure of their atoms. If we move from left to right, then we can notice that there is no increase in the number of shells. As we can see, all the elements have 3 shells in their atoms. That is K, L and M shells. But did you notice something else? When we move from left towards the right, the number of valence electrons increases. Sodium has 1 valence electron while chlorine has 7. So does that mean that the properties of elements in a period will change as we move in either direction? Absolutely. So in this period, metallic character decreases as we move towards the right. This is evident from the fact that sodium is strongly metallic. In other words, we can also say that the non-metallic character increases as we move towards the right in that period. And this is evident from the fact that chlorine is a non-metal. This is how elements form a particular period. Groups and periods help us to know the chemical properties of elements. Let's quickly recap by forming a simple table. Groups will have elements having the same number of valence electrons but different number of shells, whereas the periods have the same number of shells but different number of valence electrons. So this was a quick introduction to the modern periodic table. We have taken a look at how the elements are arranged and how the columns and rows are defined. Next, we define the trends that help us study these elements better. Do watch our next video.